Here comes the second video of logarithmic test. So the question, what is the question? X plus 2 to the power 2 x square by 2 factorial. Then we have 3 to the power 3, then x cube by 3 factorial. If you notice the pattern, we are having the nth term as un is equal to, here it is supposed that there is nothing, means this is 1 to the power n upon n factorial, 1 factorial, sorry, 1 to the power 1 upon 1 factorial. So this is basically 1 2 3 4 5. Simply we can write n to the power n x to the power n upon n factorial. All right, and the un plus 1 term is n plus 1 to the power n plus 1 x to the power n plus 1 upon n plus 1 whole factorial. So now the ratio of un upon un plus 1 term, just solve it and find the ratio. So to make this easy, I am separating the factorial terms one side and the rest of the terms other side. So n plus 1 factorial upon n factorial multiplied by n to the power n upon n plus 1 to the power n plus 1 into x to the power n upon x to the power n plus 1. Alright, now let me expand this. If I expand this n plus 1 factorial, I am getting n factorial and n plus 1. Alright, and this is n factorial, so n factorial will get cancelled. Again in this case, n to the power n upon n plus 1 to the power n plus 1. So I can write this as n plus 1 into n plus 1 to the power n. As we know, if the base are same, the powers gets added. So this is in a product, okay? So this will also get cancelled and I will left with x to the power n minus 1. Okay, shifting, both the bases are same in division form, so we are subtracting the powers. So n to the power n upon n plus 1 to the power n, and here this is x to the power minus 1. So basically it is n upon n plus 1 whole power n, and this represent 1 by x. Now can you take n as a common over here? So yes, I can easily take n as a common, and then we will put the limits. So let me take n to the power n as a common, okay, and here from the denominator also I am taking n to the power n common. So in the numerator so what I left with 1 upon 1 plus 1 to the power n whole to the power n. So this is I am getting. Now what I am going to do, I am going to put the limits, okay, I am putting limits n tends to infinity, limits n tends to infinity, this side and this side too, limit n tends to infinity. So just look at this. If I put infinity over here, it will become 0, and then the complete will become 1, and while putting infinity over here, the complete will become 1 to the power infinity. So it is 1 to the power infinity form. This means this value is e, 1 to the power infinity form. The value gives me e. So it's nothing but 1 to the power, this is nothing but 1 by e, 1 by x. Is it clear? So basically 1 upon 1 plus 1 to the power n, this is n, and I can write this as 1 plus 1 upon n to the power n as e. So basically what I am doing here, I am just writing it's 1 to the power n upon complete to the power n, and then this represent e. Okay, so my answer is 1 upon e into 1 by x. Are you getting my point or not? This is so simple. Now, so we are getting this as a ratio. Okay, so we are proving D'Alembert's ratio test. So D'Alembert's ratio test give me this result. Now this result will be convergent and divergent according as if 1 by e to the power x is greater than 1, then it will be convergent, and if 1 by e to the power x is less than 1, then it will be divergent, right? So if that's the case, then this will become x equality will get changed. X will is less than 1 upon e, and if this is the case, then e to the power ex is greater than 1, and again x is greater than 1 upon e. So basically this will be convergent if x is less than 1 by e, and this will be divergent if x is greater than greater than 1 by e. Okay, but this ratio will fail if x is equal to 1 by e. So this ratio will fail if x is equal to 1 by e. Okay, is it clear till here? Now you will question me like this, that we have studied that ratio test fails only when x is equal to 1. So here e is a very small number. E is so small that we can consider it as equivalent to 1. Okay, so that's why we are considering it equivalent to 1. That's why it's completely gives me x is equal to 1, kind of 1. Okay, to get the result we do some kinds of equivalency. Okay, so in this case you can apply the Rabi's test for your choice, as we are dealing with the logarithmic test. So I am solving via logarithmic test. So I've written the two cases on the previous page. Here I am writing if x is equal to 1 by e, this test fails. So we apply logarithmic test. So what was the earlier ratio? So un upon un plus 1, we have 1 plus 1 upon n to the power n. We can write it like this, into 1 upon x. Here we have 1 upon x. So instead of x we are having 1 upon e. We are putting 1 upon e, so it will become simply e. 1 upon e is e. Okay, now taking log on both sides, as we are dealing with the logarithmic test, we will apply the log test. So taking log on both sides, I am not writing this line, just applying un plus 1 is equal to log. Now you have to be very specific over here. If you directly write the formula of log e minus n log, that's completely fine. I'm just going with the very basic. Okay, the next step I'm doing that. So here it is log e minus log, here n is outside the log, and this 1 plus 1 upon n. So how I am doing this? I simply put the formula of log a by b, that is log a minus log b, and when you have log a to the power b, this b just comes before log, so b log a. So it's nothing but the properties of log that I have applied over here. Now log un upon un plus 1 is equal to this. Now we know that the value of log e is 1, and n, this is again in the form of log 1 plus x, log x plus 1, that we have dealt in the previous video also, that what is the formula of log 1 plus x. So I'm again writing it for your convenience. So let me switch the color of the pen. So log this is the same color, kind of. Log 1 plus x is equal to 1 upon x not 1 upon x, it is x minus x square upon 2 plus x cube upon 3 minus till. Okay, so here we are now applying it. And log x, first here x is what, 1 upon n, then minus x square by 2, so 1 by 2n square plus 1 by 3n cube. Okay, is it visible like this till infinity? Now let me put this in bracket. Okay, now what we have, log un by un plus 1, we have here 1 minus n, and here it is n, 1 upon n square, 1 upon 2n square, 1 upon 2n cube. Now if you look the format of logarithmic test, we have again n here. So if I put again n here, we have to put n in the RHS side, so this will become n and this n will become n square, and then I have 1 upon n minus 1 upon 2n square plus 1 upon 3n cube. Okay, now if I take n square common from this part, this n square can easily get cancelled, so I am just taking n square common from the denominator, so I am left with n minus 1 upon 2 plus 1 upon 3n till infinity. So this will get easily cancelled. Now in the RHS side we have the same result. Alright, now I am just doing this simplification of this negative sign. It's minus n minus minus plus 1 by 2, this is again minus plus minus 1 by 3 n, and so on. This n will get cancelled, and in the LHS side I have this. Okay, so logarithmic test gives me the result n log un upon un plus 1 is equal to 1 by 2 minus 1 by 3n. 3n, did I left something? No, is it 3n now? Alright, now here if I put the limit n tends to infinity, so from this term, the complete term from 1 by 3n will become 0, because if I put infinity over here, the complete term will become 0. So from this to the end of, means infinity, that we have so many terms, so we have 0, and I only have log un upon un plus 1 is equal to 1 upon 2. So 1 upon 2 is basically less than 1. This is what, less than 1. Okay, so logarithmic ratio test gives me that the given series is divergent. So you have to write, hence by logarithmic test, hence by logarithmic test, the given series is divergent. I hope this is clear. And this is so simple question. Yeah, this will take time in the examination. Just keep your mind calm and then solve. You can easily tackle every question related to logarithmic test. So I am not taking more question on logarithmic test. We will now deal with the question that has higher logarithmic test, because in your book you will find a lot of question which will similar to this. 1 upon ex, 1 upon x, the result will same, and then you have to solve the same way as I solved. First you have to solve what, the ratio. The first you have to solve the un by un plus 1. Then you will get a if you are concluding with the finite number, then that is very fine and okay. But if you are not getting finite number, instead you are getting some variable, that is 1 by x or 1 by e to the power x, anything like this, you can proceed with the Rabi's test or logarithmic test. So now I am taking a question in which logarithmic test is also failed. Now that will be tackled by the higher logarithmic test. So let's move into that question. So don't skip this question, because this is not the type of logarithmic test. We will not stop till logarithmic test, because this is the question of higher logarithmic test. This means this test will fail in the logarithmic test also. So I have just told you earlier. So we have a twist in this question. If you look in the pattern of the question, you will have 1 to the power p. Again, let's see the numerator first. Okay, 1 to the power p, 1 to the power p, 1.3, 135 means 137, and in the denominator we have 1, 2, 2.4246. We are getting a kind of मतलब गड़बड़ टाइप का. मतलब this pattern is very fine if I take my series from this step, from the second step. ये कहाँ से आ गया, making this series a very bad series. So neglecting the first term, if we neglect the first term of the given series, this does not affect the convergence or divergence of the given series, and then denoting the series un, we will get the same from the here that we observe. So I am neglecting this, as by neglecting this we will not, this will not affect the series, because this un will 1 to the power p, 1, 3, 1, 3, 5 means all the odd numbers I am getting, and the denominator all the even numbers I am getting. Okay, so that will make a much more sense. Okay, so what is un? So 1, 3, 5, and a representation of odd number is 2n minus 1. Okay, divided by 2, 4, 6, and the representation of even number is 2n. This is whole bracket surrounded by p. Okay, now what is un plus 1? Now un plus 1 nothing but just simply add plus 1 here upon 2, 4, 6, 2 and plus 1 here. So solving this you will get 1, 3, 5, 2n plus 2 minus 1. So you are getting 2n plus 2 minus 1 is plus 1. Alright, so now this is the one step further. One step further of which one? One step further of this one. So you can write this also over here. This is the way of solving this type of question. I have taken this type of question earlier also. So now 2, 4, 6, and this again, this is 2n, then 2n plus 2. I'm just taking one step further. Means I have written like this. This is the 2n un part, and this is the un plus 1 part. So that while taking the ratio of un by un plus 1, I can simplify it easily. So how to simplify it? Let's look into this. So un upon un plus 1 is nothing but 2n minus 1 by 2n whole power p upon 2n minus 1, 2n plus 1 upon 2n plus 2 whole upon p. I can simply cancel 2n from here, and 2n minus 1 from here. So I am left with 2n plus 2 upon 2n plus 1 whole to the power p. Okay, now for more simplification, I am taking n common from both the numerator and denominator. I am getting this as a final result. Now when I apply the limits n tend to infinity, un by un plus 1 is equal to limit n tends to infinity. This completely is becoming 0, 0. So I am left with 2 upon 2 to the power p. This is again cancelled and left with 1 to the power p, that is 1. Okay, so this is a very good question that I'm simply getting 1 as my ratio. So un by un plus 1 is 1, means this ratio fails. This ratio fails. We are heading towards the application of logarithmic ratio test. So apply logarithmic what has happened to this pen? Logarithmic ratio, apply logarithmic ratio test. So how to apply it? I'm applying it from this part, un upon un plus 1. Yes, un upon un plus 1 from this part, 2n plus 2 upon 2n plus 1 p. I'm taking 2 as a common. Here also I'm taking 2 as a common. I am having, you can also take n as a common. I'm just making it more simple, like 1 plus 1 upon n upon 1 plus 1 upon 2n power p. Now taking log both the side, let me write this in the previous page, but before that I write the log. Taking log on both sides, here also if I take log 1 plus 1 upon n to the power p upon 1 plus 1 upon 2n to the power p. So the ratio is log un upon un plus 1, and this will become basically log a by b formula, that is log a minus log b. So log 1 plus 1 upon n to the power p minus log 1 upon 1 by 2n to the power p. This p will shift outside. You know the property I told you earlier, log 1 plus 1 upon 2n. Now you know better that here comes the application of the formula log 1 plus x. I'm simply writing it log un by un plus 1 is equal to p. The formula of log 1 plus x goes like 1 upon n minus 1 upon 2 n square plus 1 upon 3 n square, not cube, dot minus p log. Here it is 1 upon 2n minus here it is 1 upon 2n, then x square by 2 होता है ना, तो x square ये हो गया 1 upon 2n 4n square, ठीक है, और एक एक्स्ट्रा 2 भी आता है, तो यहाँ पर 1 upon 8n स्क्वायर हो गया, ठीक है, माइनस 1 upon फिर एक्स क्यूब बाई 3 होता है, तो एक्स क्यूब बाई 3 यहाँ पे 1 upon 2n है, तो इसका क्यूब करेंगे तो 8n क्यूब हो जाएगा, और 8 के साथ एक 3 आएगा तो 24n क्यूब, डॉट 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 लाइक दिस. ओके, ये था एक्सपेंशन. इसमें लॉग क्यों लगाया मैंने? नाउ इफ आई टेक p एज अ कॉमन फ्रॉम हियर, log un upon un plus 1, I'm taking p as a common from both the sides. I'm having 1 upon n minus 1 upon 2n square plus 1 upon 3n cube. Then this will become minus of 1 upon 2n minus plus of 1 upon 8n square plus minus minus. Hey, I've done gadbad ghotala over here. Now it is okay. Now this is minus of 1 upon 24n cube dot 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 dot. Alright. Now if something is getting cancelled, just find it out. If not, I'm just simplifying it So n square, if you solve this n and solve this n cube solve this, you will have 1 by 2 minus 3 by, I'm directly writing it because I have solved it earlier also. So plus 7 upon 24 n square infinity. See, you are getting the same result or not? Okay. Now put the limit n tends to infinity log un upon un plus 1 is equal to p. I'm only getting 1 by 2 because this complete will get 0. Because if you put infinity over here, you will get the result 0. So I'm getting only p by 2. Now here by logarithmic test, ratio test, the series is convergent or divergent according as, now what we did in the D'Alembert's test will repeat in this ratio test. The लिखने का तरीका, what is the लिखने का तरीका over here? क्योंकि we are not getting in a conclusion yet, so we will write that hence by logarithmic ratio test, the given series is convergent or divergent according as p by 2 अगर बड़ा होगा 1 से और p by 2 अगर छोटा होगा 1 से, means p is greater than 2 और p is less than 2, तब ये डाइवर्जेंट या कन्वर्जेंट या डाइवर्जेंट होगा. लेकिन अगर वही इफ p इज इक्वल टू 2, दिस टेस्ट फेल्स. क्या कुछ नया है? बिल्कुल नहीं, इजी है. सो वी अप्लाई हायर लॉगरिथमिक टेस्ट. अभी कोई मेरा गला नहीं पकड़ेगा कि हायर लॉगरिथमिक टेस्ट क्या होता है. क्यों गला नहीं पकड़ना है? क्योंकि मैंने डाल दिया है इसका वीडियो, कैसे प्रूव होता है, किस तरह से प्रूव होता है, बहुत अच्छे से डाला है, जाके ज़रूर देखना. नहीं देखोगे तुम्हारा लॉस है. अगर ऑलरेडी तुम देख चुके हैं तो वेल एंड गुड, नहीं देखा है तो जाके देखो. सो नाउ वी अप्लाई हायर लॉगरिथमिक टेस्ट. अप्लाई करने से पहले मैं तुम्हें बता दूँ कि हायर लॉगरिथमिक टेस्ट के हमको कंक्लूजन में लाना क्या है. दिस जस्ट फॉर सिंपल नोट कि मैं ये लिखना नहीं है. हमें लॉगरिथमिक टेस्ट में तो बहुत सिंपल रहता है, खाली अरे यहाँ तो n लगाया ही नहीं मैंने लॉगरिथमिक टेस्ट में, वही ना, मैंने n ही नहीं लगाया यहाँ पर. तो यहाँ पर आपने n छोड़ दी थी. मैं डायरेक्ट जो रिज़ल्ट लिख दी थी ना, यहाँ पर n लगा के ये रिज़ल्ट लिखा गया है. देखो, क्योंकि n लगाओगे तो n तो कटेगा ना सबसे, तो ये रिज़ल्ट आपका आना चाहिए n लगाने के बाद. सॉरी, दिस इज़ माय मिस्टेक. तो मैं ये कह रही हूँ कि जो लॉगरिथमिक टेस्ट होता है उसमें n ये फॉर्म लाना रहता है. तो हायर लॉगरिथमिक में क्या होगा? कुछ नहीं, बहुत सिंपल है. ये फॉर्म तो रहेगा ही. इसे n लॉग, दिख नहीं रहा है आप लोगों को, n log un अपॉन un प्लस 1, ये तो लॉगरिथमिक टेस्ट से आया है. इसमें एक्स्ट्रा क्या है कि एक माइनस लग जाएगा, ब्रैकेट देके एक log n लग जाएगा. बस आपको यही लाना है. और अगर ये सही से आ गया, आपका सेटिस्फाई कर रहा है, तो आप जीत गए. बस आपको कुछ करना है क्या? नहीं करना है. चलिए बढ़ते हैं आगे. देखिए, जल्दी देखिए. तो हमने लास्ट कहाँ पर छोड़ा था? यहाँ पर ये चीज़ हमें लेना है बेसिकली, n log un बाई un प्लस 1. लास्ट तो यही था ना, उसके बाद तो लिमिट लगाया. देखिए, आपको लेना यही वाला है, ठीक है. लिमिट लगाने से पहले वाला चीज़ मैं इतना बार बोलते आ रही हूँ. तो ये आप जब ले रहे हो, आई एम राइटिंग इट हियर, n, सो p इज़ इक्वल टू 2 होने पर ये फेल कर रहा है, राइट. तो log un अपॉन un प्लस 1, p को आप 2 बैठा दो, p जहाँ 2 बैठा दो, तो अंदर क्या था? 1 बाई 2 था, माइनस 3 बाई 8n था, प्लस 7 बाई 24n स्क्वायर था, ठीक है. तो इसमें क्या हो जाएगा? ये 2 अगर कॉमन ले लोगे सब में से, तो यहाँ सिर्फ 1 माइनस 3 4n प्लस 7 बाई 2 बाहर आएगा तो 12n स्क्वायर. सिर्फ यही बच रहा है, इन्फिनिटी. अब हायर लॉगरिथमिक टेस्ट में मैंने क्या कहा? एक -1 एक्स्ट्रा हो जाएगा, राइट. तो -1 एक्स्ट्रा हो जाएगा, मतलब ये वाला n आप इधर कर सकते हो -1। अगर आप नहीं करना चाहते हो, -1 दोनों तरफ लगा सकते हो, तो ये n 1 कट जाएगा आपके हिसाब से, आप जैसा भी करो। सो log un/un + 1 -1, और क्या होता है, ब्रैकेट क्लोज करके log n लगता है, ठीक है। तो मैं क्या की, इसमें भी वही करना है, यहाँ पर पूरा में -3/4, यहाँ पे n जो है ना वो कॉमन आ रहा है, n कॉमन ले लेते हैं, कॉमन ले लेंगे तो +7/2n माइनस, यहाँ पर log n एक्स्ट्रा लगाना है और बाई n मैंने कॉमन ले लिया, ठीक है। अब इस फॉर्म में आ चुका है, मुझे इस फॉर्म में अब लिमिट लगाना है, लिमिट n टेंड्स टू इन्फिनिटी n log un/un + 1 - 1 log n, यही है हायर लॉगरिथमिक टेस्ट इज इक्वल टू, जब इन्फिनिटी लगाओगे यहाँ इन्फिनिटी, ये इन्फिनिटी, आप देखो ये इन्फिनिटी, आपको पता है कि नहीं मैं नहीं जानती, बट लिमिट n टेंड्स टू इन्फिनिटी अगर log n/n ऐसा है तो वो ज़ीरो होता है। भाई ये वाला हम आ गया जहाँ तक, तो पूरा तो ज़ीरो हो गया, आपको देखना ही नहीं है, डायरेक्ट आपका ज़ीरो हो गया। और ज़ीरो जो होता है <1 होता है, छोटा होता है 1 से, मतलब ये भी क्या है, डाइवर्जेंट, हेंस बाय हायर लॉगरिथमिक टेस्ट द गिवन सीरीज इज divergent where p is equal to 2। क्या मैं आप लोग को समझा पाई हूँ? अगर पाई हूँ तो लाइक करना और कमेंट करना कि समझ आया, नहीं समझ आया वो भी कमेंट कर देना, ठीक है। चलो बाय बाय, मिलते हैं नेक्स्ट वीडियो में।